Hey guys, welcome back. In this video I want to solve this definite integral. The integral runs from 0 to pi by 4 1 minus tangent raised to 4x dx. Okay, and I found this integral in one of the Instagram videos, so I felt it is very interesting, so I felt like it will be very interesting to solve. So if you observe very carefully, we can write this as 1 squared minus tangent square x whole squared, right? So this is the differences of the two squared, so we can write 1 plus tangent square x times 1 minus tangent square x, right? And from Pythagorean identity we can write this as secant square x, right? So we can modify this integral as going from 0 to pi by 4 secant square x 1 minus tangent square x dx. I feel like the substitution method will work best for this integral. Now let me assume that let 1 minus tangent square x equals to t, okay? Then it will imply that tangent x will be 1 minus t whole root, right? Now we have to also take care of the limits. So what happens is when x equals to pi by 4, then this tangent x will be 1, so t will be 1 minus 1, so it will be 0, right? And when x equal to 0, tangent 0 is 0, so 1 minus 0 is 1, so t equals to 1. So we took care of this, and we also know that this one, so we have to differentiate this, so we will get negative 2 tangent x secant square x dx due to chain rule will be dt, okay? And we know that this secant square x we can replace here, right? So I will solve for secant square x dx. It will be negative 1/2 tangent x, right, and dx and dt. And what is tangent x in terms of t, which is 1 minus t root, right? It will be negative 1 divided by 2 root of 1 minus t dt, okay, is secant square x dx. Okay, now we will get integral from 1 to 0, so it will be t times negative 1/2 root of 1 minus t dt, right? So it will be half from 1 to 0 t divided by 1 minus t dt. So if you get in this form, then the best way is to remove this radical in the denominator. So to remove this, I have to do another substitution. This time I will set let s equals to 1 minus t whole root. So it will be now s squared equal to 1 minus t, okay? And here also we have to take care of the limit, okay? So when t equals to 1, this one, then s will be 1 minus 1 whole root, so it will be 0, right? And when t equals to 0, here when t equals to 0, then s will be root of 1, so it will be 1. Now our integral will go from 0 to 1, okay? And we also have to differentiate this for the substitution, so we will get 2s ds equals to negative dt, and 2s ds negative equals to dt, okay? Now we are ready to substitute, okay? Now our integral will be from 0 to 1, right? And we have negative half t. What is t? Is 1 minus s squared divided by root of 1 minus t is s times negative 2s ds, okay? So it will be, now negative will cancel, 2 will cancel, s will cancel, so we'll get 0 to 1 minus s squared ds. So now we got very simple integral here, so we can simply split this integral. So we will get integral of 0 to 1 ds minus integral of 0 to 1 s squared ds. So it will be s from 0 to 1 minus s cubed divided by 3 from 0 to 1. Now we can evaluate this limit. It will be 1 minus 0 minus 1 by 3 times 1 minus 0. So it will be 1 minus 0 is 1 minus 1 by 3 times 1 is 1 by 3. So the answer will be 2 by 3. Okay. Therefore, the integral from 0 to pi by 4, 1 minus tangent 4x dx converges to 2 divided by 3. So this is the answer. I hope you all have enjoyed this video, and I'll see you in next video. Thank you.